The Big Freeze. Of all the ways the universe could end, this one is considered the most likely, which is unfortunate because it is also one of the most depressing things you will ever hear. The universe is expanding, has been since the Big Bang, and it is not slowing down. As it expands, everything gets further apart. Galaxies drift away from each other, stars spread out, and over an incomprehensible stretch of time, the fuel that keeps everything burning starts to run out. Stars die. New ones stop forming because the gas clouds that birthed them have thinned out too much. One by one, the lights of the universe go out, and nothing new switches on to replace them. Eventually, the universe reaches something called thermal equilibrium. Every corner of existence settles at the same temperature, just barely above absolute zero. No heat flowing anywhere, no energy exchanging hands, no movement of any kind. Just an infinite expanse of cold, dark, silent nothing stretching on forever. The technical term for this is heat death, which sounds almost peaceful until you sit with it for a moment. Every star, every planet, every living thing that has ever existed across the entire history of the universe, all of it building toward an infinite frozen void where absolutely nothing happens, and it stays that way forever. The Big Rip. Imagine someone slowly turning up the volume on reality. Not sound, but the force pulling everything in the universe apart. At first, you would not notice. Galaxies still hold together, solar systems still function, everything seems fine. But the dial keeps turning, and at some point it passes the point of no return, where the expansion of the universe becomes stronger than every force holding matter together. That is the Big Rip. And unlike most of the other endings on this list, it does not just kill everything, it unmakes it. Dark energy is the force responsible for the universe expanding. Right now, it appears to be holding steady, pushing everything apart at a consistent rate. But scientists are not fully convinced it will stay that way. If dark energy intensifies over time, the expansion does not just continue, it accelerates beyond any natural limit. Galaxy clusters would be the first to go, pulled apart faster than gravity can hold them together. Individual galaxies would follow, solar systems after that. At a certain point, planets would be torn away from their stars, oceans ripped from surfaces, atmospheres stripped away, everything progressively dismantled by the expanding fabric of space itself. In the final fraction of a second before the end, the force becomes so extreme that even atoms cannot hold themselves together. Every piece of matter in the universe, every particle of everything that has ever existed, comes apart at the same moment. Scientists estimate this could happen around 22 billion years from now. The universe is currently 13.8 billion years old. For context, that means we are more than halfway there. The Big Crunch. Every theory we have covered so far assumes the universe keeps expanding. The Big Freeze, the Big Rip, both of them rely on the idea that the expansion that started with the Big Bang never stops. But what if it does? What if at some point gravity wins? That is the Big Crunch. Right now, the universe is expanding, and that expansion appears to be accelerating. But our understanding of dark energy is incomplete. If it weakens over time, if gravity gradually gets the upper hand, the expansion of the universe slows, stops, reverses, and everything that has been flying apart since the beginning of time starts falling back together. It would start slowly. Galaxies that have been drifting apart for billions of years begin drifting back toward each other. The night sky, which has been getting emptier as galaxies move beyond our observable horizon, starts filling up again. More galaxies visible, then more, then closer, until the sky is blazing with light from thousands of converging galaxies, all collapsing toward the same point. As everything compresses, temperatures rise. Stars get cooked by the ambient heat of the collapsing universe before they even burn out naturally. Galaxies merge into each other. Matter compresses tighter and tighter until the distinction between individual objects stops meaning anything. Everything in the universe, every star, every planet, every atom of everything that has ever existed, crushed back into a single point of infinite density. The same conditions that existed at the very beginning. Which raises an uncomfortable question. If the universe collapsed into that state once before and exploded outward, what is stopping it from doing it again? The Big Bounce, the Big Crunch is terrifying on its own. The entire universe collapsing back into a single point of infinite density. Everything that has ever existed crushed into something smaller than an atom. But some physicists think that is not actually the end. They think it is a reset button. The Big Bounce theory proposes that when the universe collapses into that single point, the pressure becomes so extreme that it does not just sit there. It explodes outward again, a new Big Bang, a new universe expanding from the same point, with new laws of physics, new constants, new galaxies, new stars, new everything. And that universe eventually collapses too, bouncing into another and another, cycling through an infinite series of expansions and contractions with no beginning and no end. Which sounds almost comforting until you think about what it actually means. Every civilization that has ever existed, every discovery ever made, every piece of art, every moment of human history, erased completely with each collapse. Not preserved somewhere, not carried forward into the next cycle, just gone. The next universe starts from zero with no memory that any of it ever happened. And if the theory is correct, this has already happened an infinite number of times before our universe began. There have been countless universes before ours, each one expanding, collapsing, and vanishing without a trace. Civilizations that may have been billions of years more advanced than us, gone without a trace. Vacuum decay. The universe as we know it might not be in its lowest possible energy state. Think of it like a ball sitting in a shallow dip on a hillside. It is stable enough, it is not going anywhere, but it is not at the bottom of the hill. If something nudges it out of that dip, it rolls down to a lower, more stable state. Physicists call our current state a false vacuum, and if that is what we are sitting in, there is a lower state available, a true vacuum. If a true vacuum bubble formed anywhere in the universe, even for a fraction of a second, it would immediately start expanding outward at the speed of light. Inside that bubble, the laws of physics are different, not slightly different, completely rewritten. The fundamental constants that govern how matter behaves, how atoms hold together, how forces interact, all of it replaced by something else entirely. There is no surviving it. There is no detecting it coming. It travels at the speed of light, which means the information that it exists cannot reach you before it does. One moment, everything is normal. The next moment, the laws of physics that have governed your existence since the beginning of time no longer apply, and neither do you. The worst part is that a true vacuum bubble could have formed somewhere in the observable universe already, right now, expanding toward us at the speed of light, and we would have no idea until it arrived. The black hole era. This one does not end with a bang. It does not end with everything being torn apart or crushed together or rewritten by a bubble of impossible physics. It ends with waiting. An incomprehensible, silent, empty stretch of time so long that the numbers required to describe it stop having any real meaning. Here is how it goes. Stars burn out. The last one flickers off somewhere around 100 trillion years from now, which is already about 7,000 times longer than the universe has currently existed. After that, the lights are gone permanently. No new stars forming, no heat, no light. Just dead stellar remnants drifting through an expanding void. Then matter itself starts to decay. Protons, the building blocks of atoms, are theorized to eventually break down over timescales so large they make 100 trillion years look like a Tuesday morning. Planets dissolve. Dead stars crumble. Everything solid that has ever existed slowly comes apart at the atomic level until the only things left are black holes. And black holes, it turns out, are not permanent either. Stephen Hawking theorized that black holes slowly leak energy over time through a process called Hawking radiation, incredibly slowly. A black hole the mass of our sun would take around 10 to the power of 67 years to fully evaporate. The largest black holes in the universe would take incomparably longer, but eventually, one by one, they go too. The last black hole evaporates. The final particles it releases drift apart into an infinite dark void, and that is it. No matter, no energy, no movement anywhere in the universe. If you enjoyed this video, make sure you subscribe for more videos just like this one, and check out the playlist in the description if you want to keep going. Thanks for watching.